Coding is a hot career skill. I see countless articles and social media commentary on the need for coding skills. If you're a programmer project manager in a technology industry, you need to be conversational when it comes to software code. And there's no better way to be conversational than to write your own software and see it work. I created this video so anyone, not just a programmer project manager, can write a bit of software and see it come to life. I chose Python as the coding language. Python is popular, powerful, and is a great place to start for beginners. However, this video is not a step-by-step tutorial. You'll need to do some of your own homework. Think of this video as a detailed roadmap. I provide an overview of the code, and the code is open source, available to you on my GitHub page. For this web application, let's get our lingo right, web app. I designed a U.S. National Public Radio, NPR station finder. The user enters a search parameter, either a U.S. city or station call letters, and the app returns the results in the form of a table entry. Moreover, the app provides weather data, summary and temperature for the station city. Let's get started. You'll need a few things. First, I use PyCharm, an integrated development environment, or IDE. Developers often use command line interfaces, but those can be cryptic. An IDE takes care of some details, plus I like the visual aspect of seeing what I'm doing. I purchased the Pro version since it has the Flask framework feature. Second, sign up for a GitHub Pro account. Most developers use the free version of GitHub. However, the free version does not offer private repositories. Everything is public. By the way, we refer to repositories as repos. While I do make this code available in my public repo, I continuously deploy from my private repo since I provide authorization tokens to the application programming interfaces or APIs. Safety tip: please don't share sensitive data in a public repo. Third, sign up for a Microsoft Azure Cloud account. Although Microsoft offers generous free trials for new users, I chose to purchase a support plan to get the features I wanted for this app. Along with the Azure Cloud account, I created an Azure Map service for the app. I needed this to generate latitude and longitude for our weather API. Furthermore, Azure and GitHub integrate nicely. After all, Microsoft owns GitHub. I enabled continuous deployment from GitHub through Azure's Deployment Center using Azure's Kudo build pipeline. Finally, you'll need to sign up for API accounts with NPR One and Dark Sky Weather. Let's take a quick look at the finished web app. It's a clean user interface without decoration. The results are in a table format. I included a banner image. You can supply your own image and reflect your personality. Here are links to the source code and the working web app. Keep in mind, the NPR One API personal account limits the number of daily calls to 300. If you pound at the station finder, you'll hit the limit, for all of us, for that day. And to be clear, this is a development website. In no way is it production quality. Let's dig into the architecture. On the left side, you see the startup and page weather refresh components. The right side shows similar components for a new station. I'll summarize the code for all of this later in the video. Furthermore, we'll use this diagram as our video roadmap. Now let's get into the code. After all, this is a Python app. One of the first tricky items is importing the right libraries and functions. PyCharm is a godsend for managing this. As I mentioned, we're using the Flask framework. In addition, you see three main functions we need: NPR One Access, Dark Sky Access, and genLat_long. Moreover, we've defined a station Python class. We'll talk through all of these. We first create empty lists to hold our stations and old stations. Next, I put in logic to generate test data and test modes. This helps get around the daily API call limits during debug. It's easy to blow by 300 calls when I'm trying to fix a bug. This helped a lot. Our station class is where we store both attributes and methods. You can see typical radio station attributes such as city, station, frequency, as well as the weather summary and temperature. For now, I've just one method, append, for adding new stations to our list. In the code, you'll notice placeholders for API credentials. These will come from your accounts. As I mentioned earlier, please be careful not to publish your credentials on GitHub. If you accidentally commit them to your repo, you'll either need to change your credentials with the API provider or delete your repo and start a new repo. Additionally, take a few minutes to familiarize yourself with Git terminology such as commits and pulls. Even if you delete accidentally published credentials, your commit history will still contain that sensitive data. All the more reason to start with a private GitHub Pro repo. Let's move on to retrieving our station data. I use a simple text file storing station data. For app startup, we need to retrieve our data for initial display on our page. This is where we start populating our old station data. In other words, previously stored stations. Let's update our weather conditions. First, you might wonder why we're checking for no station found or NPR daily call limit exceeded if we're just starting. The app stores all search history and results in the text file. This creates stateless operation where our app does not have to remember such details during a user session. We simply skip over those records and will reuse the code later in our app for new stations. getLatLong is a function that I wrote that retrieves the latitude and longitude from a station's city, state, and uses the Azure Map Services API. We'll look at that function later in the video. We need to always test for valid data in an effort not to crash our web app. In this case, we check for a valid response from the getLatLong function. Once we have a valid latitude and longitude, we call the dark sky access function, passing it the latitude and longitude. Again, we check for a valid weather response. If we receive a valid response, we save the weather data. Otherwise, we store unavailable for our response. Notice a few Python syntax examples. The double equal sign is how we compare two items for equivalent value. In this case, a logical true versus false. We index into the weather list using descriptive indices such as summary and temperature. This makes it easy to write code rather than remembering cryptic numerical references. Finally, Python has a powerful string capability, so be careful with string manipulation. Here we use weather summary as a text string while weather temperature is an integer, hence the int surrounding the weather temperature. Closing out this section, we create an instance of our station class called oldStation and append our oldStation data to our stations list. Furthermore, we close our text file with Python's file close method. If we skip this step, we'll get lost when trying to read the file later in the code. After all this work, let's render our page when a user goes to our website. At this point, you'll start to see reused code. When the user requests our page, we'll render it with updated weather information following similar logic to our startup sequence. Note, in this section, we create two new lists, one for duplicate station call letters and the other for duplicate cities. We do this to prepare for the possibility a user will search for a station we already have on display. In the latter case, we simply refresh the weather but create a new table entry. If this is a new station search request, we use our NPR One Access function and conduct the query. We check for a valid response and then start populating our new station variables. For the new station, we capture the weather, reusing our earlier code. In addition, we now check to see if we exceeded our daily NPR API call limit. If so, we store that message. Closing out this section, we create a new instance of the station class, append it to our stations list, and append the new station to our text file. Note the A+ qualifier in our file open method. We're adding the new station as our new line in a file. For this reason, I mentioned it's important to not get lost when we're writing our file. In other words, we might corrupt our text file and break our website. So far, we've focused on the Python app. However, we do need a web page. This is how Flask Framework helps us. I'm not spending time on an HTML tutorial, but let's breeze through the HTML web page. It's available in my GitHub repo under the Templates folder. We give the page a title, National Public Radio NPR Station Search. Second, add some CSS styling. Third, I created a Jumbotron class container with banner information and disclaimers. You want to supply your own banner image. Fourth, provide a simple navigation bar. Fifth, provide the user search parameter submit box and button. And finally, create a page table to display our station results. Hey, we've managed to get through the main app. Now let's spend a few minutes looking into the functions that power much of this app. First, the Dark Sky Access function takes care of accessing the Dark Sky API. You see how we construct the weather string for the API endpoint. We check to make sure we're not in test mode and then make the API call using the request library get method. We extract our JSON data with another library method, json.loads. Of course, we ensure we receive a valid response and retrieve the weather data. If we need to generate a test file, here's the place we do it. On the other hand, if we're in test mode, we read our weather data from a previously stored text file and return stored data to our app. The NPR One Access function is the most complex of our API calls. For starters, NPR One uses OAuth 2.0. Consequently, our authorization token is handled differently. As with the weather data, we include logic to generate and read stored NPR station data, avoiding the daily call limit during debug. Otherwise, we make the call. Note that NPR's current API is v3. This is common in that APIs often get revised to add features or make changes. This is something that might break your code if the API supplier makes an unexpected change. We check for a valid response. For station data, I add extra logic to build code resiliency. An HTTP response of 200 indicates a valid site response. However, this does not mean that a specific station's data is good quality or even present. So I do a quick check to ensure the response is not blank. The next checkpoint is ensuring we did not exceed the daily limit. In this situation, our specific response code is 429. Finally, as another resiliency feature, in case a station passes bad data, I use Python's try and except clauses. We try to retrieve the data, but if something goes wrong, the software doesn't crash. We simply declare the station as invalid. By all means, make use of Python's powerful exception capabilities to build resilient code. We finish up NPR One Access by returning our station data. In contrast to our NPR One Access function, the gen.lat.long function is simple. We pass the Azure Map service our station's city and state using our request library, and we check for a valid response and return our data. We've covered a lot of ground on creating a Python web app that runs in the cloud. Try it. I'm available for questions. Good luck.